Hello, today I'm going to present about assessing market penetration, combining scenario analysis, Delphi, and the technological substitution model. Contents are followed. The object of the research is to forecast the market diffusion potential of OLED TVs, a hybrid qualitative and quantitative forecasting framework. By integrating scenario analysis and Delphi methods and the technology substitution modeling. Introduction. In high-tech industries, it is common for new generation technologies to replace older ones. However, multi-generation diffusion models have been suggested to explain generational substitution of high-tech products. They may be inadequate when multiple generations coexist in the market. And the technology substitution model was proposed to describe how a new technology gradually replaces an existing one. This model was later extended to be applicable in environments where multiple generations of technologies and produce coexist. To analyze the market diffusions of OLED TV as an emerging technology, this study applies an integrated framework that combines scenario analysis, Delphi method, and technology substitution modeling. By using a technology substitution model to quantitatively predict the market share of OLED TVs and existing technologies, this study aims to provide both qualitative insights and data-driven forecasts. Research extended this framework into a multi-generation technology substitution scenario. First scenario is growth spaces. The new technology spreads across the market following a logistic growth curve. Second one is saturation phase, which completes replacements of the existing technology, and the growth rate decelerates and deviates from a logistic trajectory. A decline phases is the gradually exist the market returning to a logistic form as it phase out. First equation is the market share transition prediction model, and second equation is decline point determination formula. The Delphi method typically follows a round-based approach. First round is experts individually forecast based on the predefined list of scenarios or events. Second round is the responses are statistically summarized and shared with the participants. Third round is experts make final forecasts based on the summary statistics and group feedback. The purpose and utility of the Delphi method is effective in reducing opinion gaps among experts, and when combined with scenario analysis, it exchanges the realism and the validity of the scenarios. Methodology for presents research. The entire research process consists of 7 steps, which are explained by dividing them into 3 stages. First stage is scenario development. First step is identify the decision focus. In this stage, establish the basic direction, a direction of the study of the clearly defining the forecast period, research scope, and target technology. Second step is key decisions factors. Key drivers that may influence the market diffusions of OLED TVs and identified. These key driving factors are subsequently used to structure scenario and define forecasting variables. Third step is analysis of state of driving forces. Expert opinions were collected on external environmental factors that may influence each KDF. The collected data were used to construct an impact and uncertainty matrix. Fourth step is select axis of uncertainty. A driving force with high impacts and medium uncertainty or medium impacts and high uncertainty were selected and used as the axis for scenario developments. Stage 2 is quantitative forecasting and scenario reinforcement. Fifth step is scenario selections and reinforcement through the Delphi method. Using the Delphi method, expert opinions were collected to derive the most optimistic scenario. In the first round, each expert provided feedback on the scenario based on the statistical summary. A second round questionnaire where developments and predictions were gathered again. Through this process, a consensus was reached on key values such as market share and the expected timing of exchanges for each event. Sixth step is market share forecasting using technology substitution models. Based on the Delphi results and scenario constructions, the market share of each technology is quantitatively forecasted. The third stage is deriving strategies and implications. Seventh step is strategic analysis for each scenario. Based on the forecast results derived from each scenario, strategic implications are analyzed in three key areas. First area is market entry strategies for OLED TVs, and second one is comparison with competing technologies. Last one is directions for policy and investment. This stage is directly linked to the decision-making focus established in step 1 and is intended to support final strategic judgment. Overview of the TV industry technologies. To assess the market diffusion potential of OLED TV technology, a comparative analysis was conducted on the technical characteristics. Each technology is classified according to the display method and the generation of TV technology. First one is CRT, LCD, PDP, RP, and OLED. CRT dominated the TV market in 1950s, but its market share has declined with the emergence of new generation flat panel displays like FPDs. The advantages of CRT is low cost and high resolutions. However, the disadvantages is bulky, heavy, and heavy energy consumptions. Also, less competitive compared to newer technologies. As of 2007, it held a 46% market share, but it is now being phased out and it is even being replaced by LCD. LCD TV development began in 1970s. It was initially used mainly for small devices and only entered the TV market in around 2003. The market expanded as fifth and sixth generation panel factories began producing 26 to 30 inches TV. Advantage of LCD TV is slim and lightweight. As of 2007, it had the highest market share at 46%, and it is expected to remain the mainstream technologies for the next 10 years. PDP market share increased alongside the growth of digital broadcasting, but later declining due to the rapid expansion of LCDs. Disadvantage of PDP TV is high power consumptions and burn-in issues. In 2007, 11.3 million units were sold, but future prospects appear challenging due to the competitions from LCD and RP technologies. RP-TV commercialized in 1970s and the picture quality was initially inferior to that of CRTs. Since 2002, the technology has rapidly advanced, particularly with improvements of large screens over 50 inches. Disadvantage of RP-TV is bulky and heavy requirements maintenance and has a narrow viewing angles. Due to competitions from LCD and PDP technologies, shipment volumes began to decline from late 2007. OLED TV is organic emitting materials began in the 1950s and commercializations became feasible in the 1980s. Advantage of OLED TV is it doesn't require a backlight, enables ultra-thin and flexible displays. Disadvantage of OLED TV is limited material lifespan. High manufacturing costs and low production yields create technological bottlenecks. OLED products were initially introduced at a price nearly 10 times higher than LCD. Although the growth potential is high, stabilizing both technology and production processes remains a critical challenge. Next one is the OLED TV market. Let's do step 1 at the OLED TV market. The focus is on how OLED TV will evolve in the global TV market over the next decade under different scenarios. The market share of each TV technology is projected for each scenario. Second step is identify KDFs. Factors were categorized into 4 groups based on interviews with 15 industry experts. First one is global environment, second one is industry structures, third one is technology development, and the last one is market demand. According to expert evaluations, production cost, TV price, consumer preference, technological advancements, and government policies were identified as the most influential factors. The KDFs were analyzing by categorizing them into macro and micro dimensions. A macro dimension is social, political, economic, and technological factors. Micro dimensions is technological capabilities, competitiveness, and market demand. Based on expert opinions on impact, uncertainty matrix was constructed to derive key scenarios, and you can see on table 1. Our first step is select of uncertainty axis. 3 key scenario axes were identified based on high impact and high uncertainty KDFs. Our first axis is consumer demand and preference. Second one is paces of technological developments in TV, and last one is consistency of government policies and manufacturing strategies. Based on these 3 axes, 8 distinct scenarios were developed. Experts used Delphi methods to vote on and discuss the most optimistic, pessimistic, and most likely scenarios. The final 3 selected scenarios were stable growth, broad penetration, and niche. Sixth step is market share forecasting using a technology substitution model. Forecasted values are presented for the years 2008, 2013, and 2018. The input data consists of TV shipments volumes from 1992 to 2007, and the forecasts are based on technology substitution model, equation 1 and equation 2. The most optimistic scenario is stable growth. Economic growth, policy consistency, and strong consumer demand for large, high-definition displays all have positive effects. OLED production's bottlenecks are overcome and enabling mass productions, which leads to price reductions and increased demand. OLED TV market share in 2018 is 12%, and LED remains the mainstream technologies. And PDP peaked in 2008 at 2.79, but it decreased. And the most pessimistic scenario is low penetration. Really, the technology's bottlenecks persist, resulting in low production efficiency and lack of price competitiveness. Weak consumer demand and the slowest digital broadcasting demands and manufacturing avoid investing. OLED TV markets in 2018 is 1.01%, and LCD peaks in 2027 at 95%. PDP peaks in 2012 at 12%, but it is also decreased. The most likely scenario is niche. Economic growth continues and there is steady demand for high-definition displays. Although technological bottlenecks persist and OLED can secure niche markets. Strategic alliance and marketing among companies help differentiate OLED. OLED TV market in 2018 is 8%, LCD is 81%, and PDP peaks in 2011 at 20%. In stable growth scenario, OLED TVs overcome technological bottlenecks and successfully enter mass productions. In these cases, the enterprise should do expansions of joint R&D investment to accelerate the commercialization of OLED technologies. Also, they need to build brand trust because OLED TVs are high-priced products, so establishing a premium image is essential for early market penetration. Last strategies is securing global authorizations, and policy support. Aligning with government's technology incentives and eco-friendly policies is advantageous. In low penetration scenarios, these scenarios assumes that OLED technologies continues to face bottlenecks, making mass productions unfeasible and resulting in extremely low market share. And so they need to focus on resolving key technology bottlenecks, like securing production stability or extending the lifespan of blue OLEDs. Also, they reevaluate product differentiation strategies. If OLED fails to dominate the mainstream market, alternative display technologies or hybrid models should be considered. Last strategies is consider market exist or niche focus. If profitability doesn't recover after a certain point, a complete revision or withdrawal of the OLED strategies may be necessary. In niche scenario, OLED still faces technical limitations, but manages to establishing a niche market among certain consumers segments seeking high picture quality and slim designs. In this scenario, the corporate should focus on niche market, tailored product development targeting the premium home appliance segments, design-centric TVs, or consumers seeking high-end visual experiences. Also, they should do international collaborations and brand differentiation. Some technological gaps in OLED can be addressed through cross-licensing of patents with global firms. Last strategies is policy linkage with governments, emphasizing energy efficiency and eco-friendliness makes it possible to align OLED development with green industry policies. Conclusion. A structured applications method for scenario analysis is proposed, integrating the Delphi techniques throughout the entire scenario development process to ensure consistency in expert forecasting. By using a technology substitution model to quantify future market shares, the study overcomes the limitations of purely qualitative scenario analysis. The limitation of this research is OLED TV is a relatively new technology, and the limitation exists due to the lack of long-term empirical data. Also, as the forecasts are based on the scenario analysis, there is possibility of deviations from actual market developments. It is also worth exploring the applicability of this model to other industry or technology sectors. Thank you.